Hello guys, welcome back to another video. In this video you will learn how to use QGIS software package to create a geological map from a dataset that we download completely for free. I'll be guiding you through the entire process, and I'll also give you an insight to some of the free sources from which you can obtain spatial data in case if you find it hard to get access to geospatial data that you need. So once we create the map, this is how the final product is expected to look like. And we are going to get started from absolutely zero, and I'm going to get you to this point step by step so that you could later on extrapolate the skills that you gained from this tutorial to make a map of your own with your own configurations and all that good stuff. So before we jump in and get started, I would like to give you a quick reminder that I have done the same exercise that we are going to do right now using ArcGIS ArcMap software package, and if you're interested in checking that out, you can click the link that's appearing on the top right corner of the screen. So with that out of the way, let's get cracking. First thing first, where exactly are we going to source the data from? So if you head over to Google and search World Geologic Maps USGS, you can head over to the very first response that you're going to get. By the way, I'll just copy this link and put it down in the description as well. So in case if you cannot find this particular link, or if you happen to get a different response for some reason, you can just head over to the description of this video and click on the link that I have provided. So once you access this link and open that up, you will be directed to this World Geologic Maps page by USGS. Now, as you can see over here, they have provided geologic maps for almost every region on Earth. So we have Africa, Arabian Peninsula, and we have Asia Pacific, and we have Caribbean, European region, and former Soviet Union. So what's quite convenient is that along with the shapefiles, they also actually have provided some sort of a publication. So in case if you have some doubts or some additional concerns about the data that you're actually referring to, you can always head over to this publication and try to see what they have actually explained over there as well. Now, for the purposes of this tutorial, I will be actually downloading the geological data pertaining to Europe. So right over here, you can see that we have the GIS datasets corresponding to the faults of Europe, including Turkey. And we have the generalized geology of Europe, including Turkey, that dataset, and a couple more different datasets. So what I will be going for is actually this second one. So if I click over here, you can see that immediately a zip file gets downloaded which contains the generalized geology of Europe, including Turkey, in the form of a shapefile. Now, before we go ahead and open this up, let's spend a couple of minutes to actually try to see what they have included under this entire publication option. So if I were to click over here, you can see that some sort of a document actually gets opened up. So there's a report which you can open and have a quick look over here. So in this report, they have included quite a number of helpful information that we probably might revisit in a couple of minutes when we actually go ahead and explore that shapefile that we downloaded. So let's get to the actual data that we downloaded. Now, this is my working folder, and as you can see over here, this is the dataset that I downloaded. So what I can do is I can just right click over here and extract this dataset. So basically what you have inside is a compilation of different files which basically forms an S3 shapefile. So if you would like to open this S3 shapefile, all you have to do is just use a software package, a GIS software package like QGIS or ArcGIS, and you would be able to actually view and explore the data that's kind of embedded within these different files. So as I told you guys, I'll be using QGIS for this particular tutorial. So what I'm going to do is I'm going to go ahead and open up QGIS right now. So the version that I'm having here right now is actually QGIS 3.1. However, depending on the version that you have, I don't expect that many differences, especially if you're using some sort of a 3-point version. So you don't really have to worry much about that in case if your version happens to be different from the version that I'm using over here. Alright, so this is how a fresh interface of QGIS is actually going to look like. Now what you can do is under the browser panel, you can head over to your specific working folder. And in my case, this was the shapefile that I just downloaded. And if I drag this and drop it over here, what happens is that the shapefile itself gets opened up, and a couple of things that we need to note is that immediately the coordinate reference system actually changes to be a user-defined coordinate reference system. We'll get into the details in a bit. And right over here you can see the layer, and we can right click and go to properties to inspect a couple of things. So if you go to information, you can see the exact coordinate reference system, and it has been identified as the coordinate reference system called user 10025. And as you can see, it's an S3 shapefile. And now if you try to look at the attributes table, so you can see actually quite a number of things. We have the perimeter, and we have a couple more fields. However, the field that I'll be interested in will be this field called GLG, because this GLG is actually the field that shows the different types of geological formations in terms of its period. However, if you're going through this for the first time, there's a good chance that none of these notations might actually make sense to you. So that's where that document that we referred to just a couple of minutes ago comes handy. So for example, let's say if I would like to know what this Q refers to, all I have to do is just refer back to the PDF document that was kind of attached along with this data, and that'll tell you that Q refers to undivided quaternary sedimentary rock units. And similarly, if you happen to view these two things side by side, anything with J basically would refer to sedimentary rock units of Jurassic period, and anything with P would be of Permian period. So I guess you guys get the basic idea. So it's always actually a handy thing to use this document that's kind of included along with the data as a reference, in case if you do not really know what each of these different notations refer to. And it would also be actually a handy thing to kind of transfer these explanations as a different field. However, we are going to keep that for a separate exercise maybe another time. So given that you guys now understand what each of these different actually notations refer to, we are going to actually clean up the data just a little bit, because now this data set basically refers to the entire Europe, including Turkey. And just to keep things simple, what I'm going to do is I'm going to clip just a certain part of this data using an administrative boundary of a specified or a selected country. And in this case, for no particular reason, I have selected Switzerland as the country, and I'll be using the administrative boundary of Switzerland to sort of cut off the part that I need from this particular shapefile and basically get rid of the others that I don't really need. So over here you can see there's another folder in my main working folder called Switzerland admin boundary. And what I'm going to do is I'm going to expand this folder, and over here you can see that I do have a shapefile called chf_admin0, and if I drag this and drop it over here, you can see that Switzerland basically lies somewhere over here. So all I need is this geological data that falls within the administrative boundary of Switzerland. Now before we jump into the next step, now you might be wondering where exactly you can get this kind of shapefiles, particularly if you're interested in doing this same exact thing but for a different country or a different region. So in that sense, DivaGIS is actually quite a handy web portal from which you can download the administrative boundaries of different countries, almost covering all the countries on the planet. So this is how that portal looks. If you head over to diva-gis.org, and if you go to this free spatial data tab, and if you head over to country level data, you'll be able to see that you can select the country from here. And once you have selected the country, you can pick either administrative areas or quite a number of other things that you potentially might be interested in looking at. But in this case, I think administrative areas is actually what we are looking for. So once you select the country, you can just set this to administrative areas and click OK, and a similar zip file that you saw just a few minutes ago will get actually downloaded, but for your own respective area of interest. So assuming that you guys can actually do this by yourself, I'm just going to proceed further to the next part of this tutorial, and that's basically performing an intersect operation to get rid of these unwanted parts of this geological data shapefile. Now, before doing that, before performing an intersect operation, not just for this data, but in general, when using a GIS software package, you have to always make sure that the coordinate reference systems that you're using are actually equal in both the shapefiles. Now, we already had a look at the coordinate reference system of this particular shapefile. It was called user 111000025. And I'm pretty sure that the coordinate reference system of this Switzerland shapefile is something different. Now, why do you think actually it gets placed exactly where it's supposed to be, even though it has different coordinate reference systems? Well, that's a common feature that most of the GIS software packages have, and in QGIS they call it on-the-fly projection system. So despite this particular shapefile having a different coordinate reference system, it'll geographically get placed exactly where it's supposed to be. So that's what they refer to as the transformation of the projection system on the fly as we drag and drop data into our working interface. So let's head over to this shapefile and try to go to properties and check what kind of a coordinate reference system is being used. So as I expected, you can see that the CRS that's being used by this particular shapefile is EPSG 4326 WGS 1984 Geographic Coordinate Reference System. So it's not this user-defined coordinate reference system. So before you head over to the next step and perform the intersect operation, you can either convert your geological data into this coordinate reference system, or you can convert this particular shapefile into another shapefile which has the coordinate reference system of this geological data shapefile. And I'm going to actually go with the latter option, again for no particular reason. So that means we will have to export this and save feature as. So the format will still be S3 shapefile, and the file name, we're going to actually browse and select the same working folder that we were working in before. And we can name this as Switzerland. Well, I just put a note saying that it's a user-defined coordinate reference system. So that'll be kind of self-explanatory. And it's going to get saved as a shapefile. And quite important over here, once you click, you will see that user-defined 10025 coordinate reference system. So just click over here and click OK. Alright, now you can see that we got a new shapefile. But if you head over to the properties and check the CRS, you will see now the CRS has been changed to the same CRS of this geological data shapefile. Alright, now with that out of the way, what we can do is we can actually run a simple intersect command. So to run an intersect command, what you can do is you can actually go to processing and open the toolbox. And well, one of the easiest ways to find the intersect command would be just to do a simple search. And if I were to use the Saga tools, you can see that there's actually one tool called intersect right over here. So let's open that up. And it goes without saying, to intersect two layers, what you're going to need is basically two different layers. So one of the two is actually going to be the actual geological data, and layer B is going to be the shapefile that we just created, which belongs to the administrative boundary of Switzerland, but with the same coordinate reference system as the first one. Now you can save this to a file, or you can just let it run like this and it'll get saved into a temporary file. So that's what I'm going to do right now. So let's run this and save it to sort of a temporary file. And typically from my experience, it's actually going to take a couple of seconds, probably because of the complexity of the geological data shapefile. If you were dealing with just some simple shapefiles, it's actually not going to take this much time. Alright, so once the process is done, you will get this sort of a notification saying that the task has been completed. You can just exit out from all of these different windows, and right over here you can see the newly created temporary shapefile. And what we can do is, for the time being, we can deactivate all these other unnecessary shapefiles. And it'll be quite interesting to actually go to the attributes table and have a look at what kind of fields have been generated. And as you can see, we're not really going to make use of any of these fields, but just this one, this GLG field. And something interesting that I did notice is that you can see that even for the same type of geology, it'll actually create a number of different features, just like this. Now, even though this is not going to necessarily pose much of an issue when it comes to creating a map, I would like to kind of group all these common geologies into one single feature. So that means in this shapefile, when you open the attributes table, I would just like to have one single feature, which basically is representing all the pieces of polygons that are corresponding to, let's say, Jurassic period, just to give an example. So what I'm going to do is I'm going to basically deselect everything again, and I'm going to perform an operation called dissolve. So what this dissolve operation does is it's basically kind of aggregating all the different features by a common value that's specified by us through a specified field ID. So let's see how that works. So if I were to open this up, this dissolve tool, so you can see, of course, the input layer is going to be this newly created intersect shapefile. And in this case, even though this dissolve field is optional, we definitely have to specify by which field we're going to do our aggregation. So in this case, we are going to actually aggregate our stuff based on this GLG field. If you can recall, that was the name of the field under which you could find all those different types of geologies. So once you're done with that, we can actually go ahead and run this command again. Yeah, and it didn't take much time for QGIS to kind of aggregate those together. And if I were to open up the attributes table of this dissolved shapefile, yeah, now you won't actually see that much of details when it comes to different features. And you can see that, for example, all the Permian areas are kind of aggregated together, and the same goes for, let's say, the polygons that represent the Jurassic rock units. Alright, so it's a good practice to kind of deselect everything before we exit out from this. And now I think we are almost done with the data preparation part. So now all we have to do is just add some simple styling to this so that we would be able to actually distinguish between the different types of geologies. And before I do that, I think I would like to save this file, because right now this file exists as a temporary file. So I think it's better to go ahead and export this file as a proper S3 shapefile. So all the settings, we can leave them as they are. Just you'll have to specify a file name. And in this case, I'm going to name this as Switzerland Geology, and click OK. Alright, so this would be the file that we will be actually working on from now on. And if I right click and go to properties, under symbology, you will be able to see that right now it's actually using this single symbol option to kind of color all these different polygons. So that's why you see just one uniform color. But instead, what we are trying to do is we are trying to actually assign a specific color based on the type of geology. So for that, we will have to go and select categorized. And under the categorized, it's asking basically based on which field we would like to assign those colors. And obviously that's going to be the GLG field. And we can either go with a color ramp, let's say something that's changing from a lighter color to a darker color, or these other kind of inbuilt color ramps. However, since we're dealing with a dataset that doesn't really mean anything when it comes to it changing its color from a darker color to a lighter color, or when it's actually kind of gradually changing its color from one to another, the best color assignment that we can do for this kind of data would be to actually just assign a random color ramp. So that's why I'm just going to click over here, a random color ramp, click over here, classify. And as soon as you do that, you can see that random colors are actually getting assigned to each of these different types of geologies. And if you're not really happy with the colors that were assigned automatically, you can always go back and shuffle. So let's say if I were to shuffle the colors, you can see that the set of colors actually got shuffled. And I mean, you can do this again and again, doesn't really matter. So if you would like to make changes to individual colors, for example, let's say if you want to change this color from being blue to sort of a reddish color like this, yeah, you can make individual changes like that as well. And I'm going to do such a change when it comes to representing the areas that are classified as water bodies. I think that's what this H2O refers to. So for that, just for that, I'm going to actually assign some sort of blue color so that it'll be kind of representative of the areas that are identified as water bodies. But for the rest, I'm just going to leave the colors that were assigned automatically through this algorithm. And a couple more things. There's actually one item over here called all other, and I do not really want to display that. So I'm just going to untick this over here. And basically with that, if I were to click apply over here, you can see that now the colors get actually assigned, and if you expand this, you can see the legend right over here as well. And if you're not really happy with the color assignment, you can always head back and do the changes accordingly. So from the beginning of this video until now, what we did was we actually downloaded data and we kind of cleaned up the data and we assigned colors based on the properties that we need. And from here onwards, we will be moving on to the next part of the tutorial where I'm teaching you how to actually create a proper map using this kind of a geospatial data set. In order to create a map using this data, you will have to go to project and you will have to open a new print layout. So even though we are not really going to print this one out necessarily using a physical printer, we'll still have to go through this item called new print layout. And you can just give a random name to this. So I'm just going to name this as Geological map of Switzerland. And as you can see, we get a number of different tools along with a couple of toolbars over here. So we won't be utilizing all of these tools. However, I'm just going to take you through the main tools that's going to be essential when we create a general map layout. By the way, just keep in mind that this is basically an additional window that gets opened up along with the main QGIS window. So you can always actually switch back and forth if you really find the need to do so. So first of all, what I'm going to do is I'm going to right click over here and go to page properties. And you can set the page type and the orientation. I think based on the geographical spread of Switzerland, we should be fine using a landscape orientation. But it's worth mentioning that there are actually certain regions in the world and even certain countries in the world where if you were to use a portrait orientation, that would actually really serve well. For example, if you were to actually do a map of Chile or a country like Vietnam, which basically stretches more or less vertically rather than horizontally, you would be able to make use of the map canvases real estate in a much more efficient manner. And when it comes to the page size, let's go with the A3 size page. Well, again, no particular reason, just a personal preference. And once you're done with that, we can head over to this tool called Add a New Map to the Layout. So what you can do is you can just click over here and draw a rectangle like this. So I'm actually leaving some space from all four sides because later on I'm planning to add the coordinate information on the sides as well. So that's basically the reason why I'm leaving some space on all four sides. Now you can see that we basically managed to kind of get a copy of the data that we had over here into our map layout. Now if you try to move this around, you can see that this entire rectangle actually moves around. So I'm just going to undo those two movements. So if you would like to actually move this map around without getting this entire rectangle to move around, what you can do is you can click over here on this tool, which basically lets you move the item contents alone. So if you click over here and try to move this around, you can see that now it's just a map that gets moved around, but not really this rectangle or the bounding box. However, if you would like to make specific selections, you can always head back to this arrow button and select this and proceed with the rest of the formatting. Now I'm actually going to specify a boundary for this rectangle. So by default, you can see that under item properties, you will actually get a number of things that you can do when it comes to the item properties of this map one. So what I'm going to do is I'm just going to click over here under frame, and of course you have the control when it comes to specifying the thickness. So I'm just going to set that to be 0.3 should be fine. And again, if you would like to zoom in or out just this geographical data that you have within the map canvas, you can always switch to this move item content. And if you were to just use your mouse's scroll button, you can see that the intervals by which the zooming in and out happens is actually quite large. So you don't really have much control over the size of this map. However, if you use the scroll button while holding the control button, you can see that now the intervals or the zooming intervals are quite small. So you still actually have the luxury of setting that level of zoom to be something that you're actually comfortable with. So I think for me, for the time being, I'm just going to set the zoom level of this geological map to be something like this. And in addition to this, I think it would be quite nice to add a base map to this map as well. And as I told you guys, we still have the possibility of switching back and forth between the main QGIS window as well as this map print layout. So if you want to add a base map, all you have to do is again switch back to this main QGIS window and try to add a base map from there. There are actually a number of ways of adding a base map. Now, my preferred way of adding a base map is actually through an external plugin called Quick Map Services, which is under Web, Quick Map Services, OSM, and you would be able to add an OpenStreetMap. However, if you haven't really used this before, then there's a good chance that you won't really find this Quick Map Services under this Web option. So in that case, what you can do is you can just head over to Plugins and go to Manage and Install Plugins. And what you can do is just search for Quick Map Services, and when you click over here, there will be a button to install this Quick Map Services external plugin. But I don't see that button in my case because I have already installed the external plugin, so I can just directly go ahead and use it. So assuming that you guys have actually configured that, I'm just going to go to Web, Quick Map Services, OSM, and I'm just going to add a standard OpenStreetMap as the base map. Yeah, that looks pretty cool. However, if you think that your base map is actually taking or grabbing too much attention away from the main dataset that you're trying to display or trying to portray, what you can do is you can right click over here and go to Properties and try to see whether you can actually make an adjustment to the transparency. So if you were to just reduce the global opacity just a little bit, you can see that you can kind of deviate that attention away from the base map towards the main dataset that you're trying to sort of display. So once you do that, you can open up again your print layout and you will see that automatically everything that you did in your main QGIS window will sort of get applied over here as well. Now you will see the base map just as we expected. Given that that's out of the way now, I'm just going to start adding different stuff to this map just to make it a complete map. So there will be a legend, a scale bar, a north arrow, and a title, a proper title for this map. So let's get started by adding a legend to this map. So if you head over to this tool right over here, which adds a new legend to the layout. So click once, and after that you can start drawing the legend like this. So there's a good chance that you might not really like how the default configuration is actually appearing when it comes to how the legend is getting displayed. But don't worry, we are going to make changes accordingly. What I'm going to do is I'm actually going to get rid of all of these different items that are not really necessary for us to have in this legend. So to do that, well, once you click over here and if you right click and go to item properties, it'll kind of redirect you to the item properties or the main properties pertaining to the legend itself. So if you scroll down and go through each of these individual items, you can see that you actually have control over the items individually. However, before you get rid of the layers that you don't really need, you have to make sure that you untick this auto update checkbox. And that kind of unfreezes this panel of tools, which you can use to sort of get rid of the layers that you don't really need. So in the legend, I won't be needing this OSM standard name, and the same goes for these other layers that we don't even use. So all of this can actually disappear, and you can even expand this. and see whether there are items that you don't really want to represent. Now in this case you can see that there's actually one box which doesn't really have the name. Possibly it might be referring to all the other values, and what we can do is we can even just simply get rid of that as well. And when it comes to changing the name, you really have the option to double click over here and change these individual label names if you wish to do so. But in this case, I'm just going to actually retain all of these original notations. However, I'm just going to change the name of this layer from Switzerland Geology to something like just Geology. Click OK. And similar to the main map window, now since we are dealing with the legend, if I kind of shrink all of these different options, you can see that we actually have quite a lot of control over the properties of this legend. So starting from main properties, you can go through columns, symbols, spacing, position and size, things like that. So what I'm going to do first is adjust the spacing just a little bit. And first of all, I'm just going to give some more space between this name geology and the rest of the items. So according to this classification, this geology will be referred to by this subgroup. So if I increase this below subgroup, you can see that the space between this name and the rest of the items is actually increasing. So I guess I'm alright with the 2 millimeters, or let's make it 3 millimeters, I guess. Similarly, you can actually increase the space between these individual items as well. Now since we have quite a lot of real estate over here in the map canvas, I wouldn't really mind if you were to increase the space between the different items as well, just like this. Maybe 6 millimeters would be a good point. Now since that's out of the way, we can shrink this menu and we can start increasing the font sizes so that the names of the items will be much more clear. So again, if we go to these subgroup headings, that means we're actually kind of working on this geology title. So if you want to, let's say, increase the size of that geology title to, let's say, 16 or maybe 18 and make it bold, you can do that as well. And to work on the individual items, you can always go to these item labels and do the same. So just because we selected 18 for the size, so for the individual items, I'm just going to go with something that's smaller than that. Let's possibly go with 16, and we can make the items bold as well. Yeah, just like this. And once you do that, of course, you might end up needing to do some adjustments in terms of its position. And I guess that's about it for the fonts and text formatting. However, I would like to get rid of this background white color, and all of these are basically your personal preferences. Some might prefer to have this background white color, but I guess I don't. And to get rid of that, I can expand this background option, or basically just untick this, and that'll kind of take care of the background white color. But if I do that, I would like to have some sort of frame just to group all of these different items together. So if I click over here, a frame will get appeared just like this. And with that, if you think that you would like to reposition this box again just a little bit like this, you could do so as well. Alright, with that, I guess I'm done with the legend side of things. Next, we'll try to see whether we can add a north arrow to this or not. So to add a north arrow, we can head over to this button right over here. And usually the north arrow goes to the top right corner of the screen. So we can adjust the sizing simply by changing the size of this bounding box. Next, one of the most important things when it comes to developing a map is actually the scale bar. So I'm going to add a scale bar right over here as well. And when dealing with the scale bar, you will see that you don't really have the control over the length of the scale bar. Just because you changed this bounding box, it's not really going to get adjusted accordingly as just because you changed the size of the bounding box. So there's actually a way to change the size of the scale bar as well as the length of the scale bar. What you can do is right click over here, again go to the item properties, and under the scale bar options you can see that we have the option to change things like the units and the labels. So I'm just going to retain all of these to be default values. And when it comes to segments, you can see that currently it's divided into two different segments. So if I were to increase these segments towards the right side to be more than 2, you can see that the scale bar is basically getting extended accordingly. So if I have 5 or 6 segments, you can see that the whole thing is actually getting divided into 6 different segments, and you might need to change the positioning again as well. And similar to what we did with the legend, we again might have to go to fonts and colors and well, basically change the size of the fonts. So if you click over here, you can see that you can make the fonts bold and increase the size, obviously, just like this. Yeah, now as you can see, there are actually quite a number of different things that you can do when it comes to formatting, but it's not necessary for us to actually go through all of these different things to create a basic map. But of course, no one is actually holding you from exploring these other items as well, and probably you might find something interesting that that's not going to get discussed in this particular tutorial. So it's up to you to take your time and go through the other available options just for your own knowledge. Alright, so one thing you would notice is that as you are adding stuff here and there, you might need to reposition the main map again as you populate the map with different things like legends, scale bars and north arrows. Naturally, what I would do is, again, I would go back to this move item content and try to drag this down just a little bit so that I'll make enough space to add a huge title that kind of grabs the attention of the map. Because the title is actually one of the most important things when we're creating a map. We want the title to sort of stand out. So I'll naturally be inclined to use some sort of an enlarged text when it comes to specifying the title. So to specify the title, you will have a tool called adding a new label to the layout. So all you have to do is just create a text box like this and change the title over here to something that describes the map that you're trying to create. Again, we can actually make this bold, and in this case, maybe we can go to a bit of a higher font size. Let's make it about 30, or maybe we can go a couple more steps up, about 34, I believe. And you can of course set the orientation or the alignment to be center. If you drag the bounding boxes to the edges of the main rectangle, you kind of can ensure that your title will be placed somewhere in the middle. And again, once you do that, you might be inclined to sort of move this map around just to make sure that you make use of the available space wisely. Alright guys, so we are almost done, except for the part of adding the coordinate information. So what we can do is we can select the main layout like this. And if I shrink all these different items, you can see that there's actually one option called grids. So we can add a grid simply by expanding this and by clicking on this plus sign. And when you add a grid, you will have to modify that. And the way you modify will define how your grid is actually going to get appeared over here on the map. Now, since we are dealing with a projected coordinate reference system, we can manually define what sort of an interval that you would like to have when it comes to defining the grids. So I'm just going to go with, just to get started, I'm going to go with a grid size of 100,000 meters over the x-axis and 100,000 meters over the y-axis as well. If you think that it doesn't really match your expectations, you can always go back and make the changes accordingly to the interval. But for me, I think I can get started with this sort of a configuration. However, along the way, I might actually change my opinions on that. And the next thing that I would like to do is to actually draw the actual coordinates. So if you click over here, you can see that the actual numbers start appearing over here. However, the default setting is actually not going to be ideal. For example, you can see that we have the numbering in this sort of a manner along with decimal points. There are actually 3 decimal points. However, since we are referring to huge scales, actually these decimal points do not really matter. So the very first thing that I'm going to do is get rid of this precision from 3 to 0, so that will kind of remove those decimal points. And the other thing is, I would generally like to increase the font size of these coordinate values as well. And how do we increase the font size? We can click over here on font and make it bold, and probably increase the font size to about 12. Yeah, I think that should be fine. And one thing, if you notice, for the top and the bottom, the values kind of rest on these edges. However, for left and right sides, you can see that it's kind of popping out from the boundary, from these two edges of the page. So what I would like to do is I would like to sort of change the orientation of the numbers of the left and the right side of the map. So if you go to the right side, you can see that the text formation, we can actually change that from being horizontal to vertical ascending or vertical descending. So for the right side, let's go with vertical descending so that the text will sort of get adjusted in this kind of a manner, and I'm going to do that for the left side as well. So for the left side, I will be selecting vertical ascending, and I feel like the text is actually quite close to the edge or to the border of this, or to the frame of this map. So I would like to add some space between the text and the border, and that can be changed using this option, distance to map frame. And let's make it to be about, let's set it to be 5. And when it comes to the frame style, I would still like to have some sort of a tick that's sticking out from this frame, just so that we can know that this figure is referring to this particular point. So to do that, we can actually go to frame, and instead of no frame, what we can do is we can select interior and exterior ticks. So there'll be actually a small tick that's kind of sticking out from the frame. And finally, before we finish this up, I'm going to get rid of these grids within the map because, well, there are certain cases where we think that it might be wise to actually have the grids running through the map. But for some reason, for this particular geological map, I don't really see the need to do that. And also we have the control of deciding whether we really want to have these lines crossing through our map or not. So if you go to line style and click simple line, and if you go to the stroke style, you actually can select no pen, and that's going to kind of make the lines disappear, just like this. Alright guys, with that, I guess we are pretty much done with the map. So all we are left with is basically a simple export. And to export this map into a PDF or a JPEG, what we can do is we can go to layout, export as image, head over to your working folder, and you can actually give a title, file name, geological map of Switzerland, made using QGIS. And when it comes to the export resolution, well, the higher the DPI, the higher the file size is going to be. I'm just going to stick with maybe about 150 DPI, should be fine. And after that, click save. Alright, so once your map is exported out as a JPEG, it would be interesting to head back to your working folder and see how that looks. So this is the map that just got created. So if I double click over here, this is the map that we just created using QGIS, the geologic map of Switzerland. Pretty cool, isn't it? Now, I'm not really sure whether you guys got the chance to go through the tutorial that I did before this, doing the same exact thing but using ArcGIS or not. So what I can do is I can drop the map that I created using ArcGIS over here. Let's name this as ArcGIS, and we can do a bit of a comparison between the two maps. You obviously see some differences, even though the information itself is actually going to be exactly the same, just the representation and the overall vibe when it comes to how the map actually conveys information might be a bit different because the color schemes are different and the fonts that we have used are different as well. So this was the map that I created using ArcGIS, and this was the map that we created using QGIS. However, one thing we can agree on is that both of these maps look pretty cool, isn't it? Alright guys, so that's a wrap. I hope the tutorial was easy for you guys to follow, and if you do have any questions, add a comment down below. And if you do appreciate me bringing these videos to you, hit that like button to show your support, and also don't forget to subscribe to this channel if you like to stay tuned for this kind of interesting content on a weekly basis. Thanks for watching. I'll see you again with another tutorial soon.